following video is a tutorial on how to solve triangles using trigonometric ratios. I borrowed from Mathematics Vision Project. You can go to mathematicsvisionproject.org, and the assignment is 610 if you wanted to download this worksheet. So the directions say, in each triangle, find the missing angles and sides. So I'm given this triangle here, and what's really important is this piece right here. It says here, the measure of angle C is 90 degrees. Now, because the angle is 90 degrees, that means I'm dealing with a right triangle. And that means I can use the Pythagorean Theorem, I can use any of the trigonometric ratios, which depend on a right triangle. What I mean by trigonometric ratios is, well, from our acronym SOHCAHTOA. We can use sine of our angle, which is opposite over hypotenuse. We can use cosine of our angle, which is adjacent over hypotenuse. And we can use tangent of our angle, which is opposite over adjacent. Now, if I wanted to find the measure of angle A, that means I'm standing from this perspective over here, then the 4 is my opposite side, and the 10 is my hypotenuse. Now, out of the choices here, the one that makes the most sense is sine, because sine will incorporate my opposite and hypotenuse. So that would give me sine of my angle A equals my opposite, which is 4 over 10. Now, I want to solve for my angle A, which means that I need to isolate angle A, which means I need to use the inverse of sine. Inverse of sine, those are inverses, they undo each other. I have A now by itself, and I'm going to throw this into my calculator, that the inverse of sine of 4/10, which is going to give me then the inverse of sine of 4/10, which gives me 23.6. That gives me 23.6 degrees. 23.6 will also indicate that here, 23.6 degrees. Now I also need to find the measure of angle B. Now I could use trigonometric ratios if I wanted to, or I could recognize that for this angle right here, I could use the Triangle Sum Theorem that says that the sum of all the angles of a triangle add up to 180 degrees. So I'm going to take 180 minus this 90 here, minus this 23.6, and then that's going to give me my missing angle. So 180 minus the 90 minus the 23.6 degrees, and that gives me 66.4. So 60, that's going to give me, my angle here is 66.4 degrees. If I want to find the missing side here from A to C, then I could either use another trig ratio, or I could use the Pythagorean theorem. We'll call it x. So x squared plus 4 squared equals 10 squared. So I have x squared plus 16 equals 100. I'm going to subtract 16 from both sides, and that's going to give me x squared equals 84. And then I'm going to take the square root of both sides, and it gives me x equals the square root of 84. If I wanted to simplify this, which I really should, then I'm going to do a factor tree, which would give me 2 times 42, and then 2 times 21. I could keep on breaking the 21 down to 3 times 7, but there's no pairs for 3 and no pairs for 7. So I'm going to stop there. See, I have a group of 2s. I can take a 2 out, and what's left over that's still stuck in the square root is that 21. So the missing side here is either the square root of 84 or 2 times the square root of 21. Now I said that I don't have to solve using the Pythagorean theorem. I could have used trig ratios. I could have said, for example, that how about tangent? Tangent, if I don't know this side over here, this side right here, I could use tangent of 23.6, that is opposite over adjacent, so that would be 4 over x. And then I'm going to just use cross multiplication. Tangent of 43.6 is the same thing as tangent of 43.6 over 1. Cross multiply this way, that gives me 4. Cross multiply the other way, that gives me x times tangent of 23.6. Then this is x times tangent of 23.6. I'm going to divide by tan of 23.6 to both sides. tan of 23.6. And then throw that in our calculator and we should get the same answer. So I'm going to throw this in my calculator of 4 divided by tan of, I'm going to just use the same angle up here, the 23.6. And that gives us 9.1651, which is the same thing as the square root of 84, which of course is the same thing as 2 times the square root of 21. I'm going to solve this one other way. Instead of tangent, I'm going to use, if we don't know this side right here, I'm going to use cosine. So cosine of our angle of 23.6 is equal to adjacent over hypotenuse, that is x over 10. I'm going to multiply by 10 to both sides, and that should give us the same answer. So that would be 10 times cosine of our angle gives us that 9.16. So my point is that there's multiple ways to do the same problem. Let's look at number 5. So first off, I'm going to find the measure of angle A. Well, I know the measure of angle C, that's 90 degrees. So I can use the Triangle Sum Theorem of that the sum of all the angles is 180. So 180 minus 90 minus this 20 degrees, that would give us, what, 70? So that gives us 70 degrees. Now, if I wanted to find the length of A to B, I can't use the Pythagorean Theorem because I'm given only one side of our right triangle. And so that would leave 2 missing sides, right? It would have 30 degrees plus B squared equals C squared. I would never be able to figure out what the A and B, or the B and C values are. One equation, 2 unknowns, it would be impossible. There are infinite possible solutions that will make this true. So I'm going to have to use a different method. Well, how about if this length over here, we'll call it x, from this perspective here of this 70 degrees, x is my opposite, and 30 degrees, that's my adjacent. Well, I'm going to use tangent then. Tangent is opposite over adjacent. So I have tangent of 70 degrees equals our opposite of x over 30 degrees, a length of 30. If I said 30 degrees, I apologize. I'm going to multiply by 30 to both sides, and 30 divided by 30 is going to be 1, and then throw this in our calculator. Throw this into our calculator of 30 times tangent of 70 is going to give us 82.4. 82.4. So this length here is 82.4, whatever the units are, not degrees though. 82.4 feet or yards or inches or something else. Now that I have this side here, I can use, now I have 2 sides of a right triangle, so I could plug that into our Pythagorean theorem to solve for it. So that would give me, well, 30 squared. Oh, let's just throw this in. We have 82.4 squared. And then we just square root both sides, right, to give us what C is. So we'd have then the square root of 30 squared plus, and then we're just going to use this full amount over here, this 82.42 blah, 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 squared, and that gives us 87.7. So this side here is 87.7, and it is the longest side, so that makes sense that this should be 87.7. But we didn't have to use the Pythagorean theorem. We could have used a different trigonometric ratio to find that. Since we have our angles and we have some sides, we could have used, for example, I could have used, to find this side right here, I could have used sine of 20 degrees equals opposite over that hypotenuse that I'm missing. I could have used cosine. I could have used cosine, which is adjacent over hypotenuse, cosine of this angle, which would be, it would be 82.4 over hypotenuse. I could have also looked from the other angle. We could have seen that we have sine of 70 degrees equals opposite, which is 82.4 over hypotenuse, which we're trying to figure out, h. But any of those would really work. We could actually do cosine of 70 degrees as well. Cosine of 70 degrees is adjacent over our hypotenuse equals adjacent over hypotenuse. Several different ways to solve for the same problem. Let's look at 6. All right, let's look at, I can't figure out the lengths because I'm only given one length. Actually, let's figure out the length using one of our trigonometric ratios. So A to B. So I'm going to try to figure out the hypotenuse here. So which trigonometric ratio should I use that would incorporate from this perspective here, that would be my adjacent, and this is my hypotenuse. We'll just still call it H. And so which trigonometric ratio should I use? I should use, out of our choices, of SO, CA, TOA. This is an A, not an H. And this is an H. So I'm going to use, this is adjacent and hypotenuse, I'm going to use cosine. So that would be cosine of 50 degrees equals 125 over hypotenuse. And then we're going to use cross multiplication because cosine of 50 is the same thing as cosine of 50 over 1. We cross multiply this way, that gives us 125. And cross multiply this way, that gives us h times cosine of 50. We divide then by cosine of 50 to both sides, cosine of 50. And then throw that in our calculator, and that will give us this length here. So I have 125 divided by cosine of 50. And that gives us 194.5. 194.5. That would be 194.5. So that distance here from A to B, that is 194.5. We're sort of limited on our choice on this one. We could have tried to figure out this side here instead, but we're limited on our choices of trigonometric ratios because of the limited, we're not given a lot of information at this point. The more information we're given, the more options we're given to solve for the missing side or the missing angle or whatever else. So let's find this other missing angle here of angle B. Well, if angle C is 90 degrees, then we can use the Triangle Sum Theorem of 180 minus 90 minus the 50. That's going to give us, what, 40? It gives us 40 degrees. Then we're missing this last side here, Because I have two sides now, I can use the Pythagorean Theorem, or I can use one of the trigonometric ratios. I'm going to try to find this. I'm given two sides. I can use the Pythagorean Theorem, or I'm going to use trigonometric ratio. How about using tangent? Tangent of 50 degrees equals, tangent is opposite over adjacent, so that would be x over 125. We multiply by 125 to both sides, 125, because 125 divided by 125 gives me 1 on the right side. 1 times x is just x. Throw this into our calculator. I have 125 times tangent of 50, and that gives me 148.9. Let's just round up to 149. 149. So this missing side right here is 149. So I have 149 units, inches, feet, I don't know. It didn't give me any units. All right, let's move on to the next one. I am going to figure out this missing, first of all, I know that the measure of angle C is 90 degrees, so that would mean that this is 90. I can find out this missing angle right here using the Triangle Sum Theorem of 180 degrees minus 90 minus 20, and that's going to give me 70. That gives me 70. Actually, we already calculated that, right? We calculated that this is 70 from another problem up here. 180 minus 90 minus 20 would also give us the 70 degrees. So that gives us 70. And so we just have to find, well, there's two missing sides then that we still need to find. Let's try to figure out what this side here is. We'll call this side, well, this is our hypotenuse. it's opposite the 90 degrees. Let's just call it h. And then let's pick a side, any side. Let's pick any angle, I should say. I'm going to stand from this angle over here. From this angle, 8 is my adjacent, and h is my hypotenuse. So out of our choices, adjacent over hypotenuse, well, that's cosine, so that's going to be cosine of 20 degrees equals adjacent, which is 8 over hypotenuse. Cosine of 20 degrees is cosine of 20 degrees over 1. And then we're just going to solve for h using cross multiplication. So cross multiply this way, that gives me 8. And then cross multiply this way, it gives me h times cosine of 20 degrees. H times cosine of 20 degrees. I'm going to divide both sides by sine of 20. Cosine of 20. Because cosine of 20 divided by cosine of 20 is 1. And that gives me that h equals, excuse me, 8 over cosine of 20. I'm going to throw that into my calculator to get 8 divided by cosine of 20. That gives me 8.5. So this missing side here is 8.5. It's the longest side. It should be more than what's given to me here, 8, so I think we're good here. I'm still missing AB, so I can either use, now that I have two sides of a right triangle, I can use the Pythagorean Theorem, or I can use one of our trig ratios to find it. I think we should practice using trig ratios. So in this case, I'm going to use, well, let's use tangent. So tangent of 20 degrees, tangent by definition, is opposite over adjacent. So from 20 degrees, our opposite is this side I'm trying to figure out. We'll just call it x. So x over adjacent, which is 8. Then I multiply both sides by 8, because 8 divided by 8 is 1. And then throw this into our calculator of 8 times tangent of 20, and 8 times tangent of 20. And that gives us 2.9. So 2.9. So we have 2.9, whatever it is, units, inches, feet, whatever. This was 0.9. Great, well, I hope this was helpful, and have a wonderful day.